Good day everyone! Welcome back to General Mathematics. It is still me, Engineer Omengan, to teach you exponential functions. Welcome to Exponential Function LBV GMAT 1-4.2 to 1-4.3. In this topic, our most essential learning competency distinguishes between exponential function, exponential equation, and exponential inequality. Solves exponential equations and inequalities. The topics covered in this video are definition of exponential function, equation, and inequality, and problems involving exponential equation and inequality. For our learning objectives, by the end of this video, we want to distinguish the difference between exponential function, equation, and inequality. Also, to solve problems involving exponential, equations, and inequality. Now let's determine the difference between exponential function, equation, and inequality. As mentioned earlier, exponential function is a function whose value is a constant raised to the power of the argument, normally expressed in this form, f of x equals 2 raised to x. But one distinction of exponential function is this f of x. Let's recall that a function is a set of input-output pairs. It also shows how the output is related to the input. In short, function is just like the general formula. Similar to an exponential function is the exponential expression. An exponential expression is an expression in the form a times b raised to x minus c plus d, where b is greater than 0 and b is not equal to 1. For this example, we have f of x equals 2 raised to x. But by removing the f of x, it becomes an exponential expression. Now let's proceed to exponential equations. Generally, equation is a declaration that two quantities are equal. An exponential equation is a declaration that two or more exponential expressions are equal. For example, we have here 2 squared is equal to 4. Another example of exponential equation is 3 raised to x equals 27. To make the two expressions equal, we know that x should be 3. Since it is an equation, it involves an equal sign. The property of equality for exponential equations state that if two powers with same base are equal, then their exponents must be equal. Or, if a raised to x equals a raised to y, then x equals y. Property of equality can only be performed if the quantities being equated are of the same base. In this example, we can see that the base of the two quantities are both a. Therefore, we can say that their exponents are equal as well. Next is exponential inequality. An exponential inequality is an inequality involving exponential expressions. For example, we have here 5 raised to 2x minus 5 raised to x plus 1 is less than or equal to 0. Exponential inequality is similar to exponential equation, except that instead of an equal sign, it involves inequality symbols. The following are the commonly used inequality symbols and how we read them. First, we have the greater than with this symbol, less than with this symbol, greater than or equal to, similar to greater than but with the underline here. Next is less than or equal to with this symbol. We also have the property of inequality. If a raised to x is less than a raised to y, then x is less than y. Similar to property of equality, the property of inequality can only be performed if the two bases are equal. This property of inequality can use other inequality symbols, not only the less than symbol. Now let's answer some problems. Problem number 6. Which of the following is an exponential equation? A. F of x equals 2x cubed. B. 625 is greater than or equal to 5 raised to x plus 8. C. Y equals e raised to x. And D. 2 squared times 5 raised to x plus 1 equals 500. We know that letter A is a polynomial function because of f of x. Next, letter B is an exponential inequality because of this inequality symbol. Letter C is an exponential function because y is expressed in terms of x. Then obviously our answer is letter D, exponential equation, because of the exponential expression here equated to a constant. For problem number 7, solve for the value of x in the given equation. 3 raised to x equals 9 squared. By property of equality, it is easier to solve for the value of the variable if we have the same base. So, let's express 9 with base 3. So, 9 is 3 squared. So, by loss of exponent, we know that if we have a raised to m raised to n equals a raised to m n. So, if we have here 3 squared raised to 2, then we have 2 times 2 equals 4. Therefore, we have 3 raised to 4. Now, from here, we will have 3 raised to x equals 3 raised to 4. And by the property of equality, a raised to x equals a raised to y, then x equals y. Again, if we have the same base, then we can also equate their exponent. Therefore, x is equal to 4. For problem number 8, solve for the value of x in the given equation 3 raised to 2x equals 9 raised to 5x minus 4. By loss of exponent, we know that a raised to mn is equal to a raised to m raised to n. So, if we take 3 raised to 2x here, we can say that 3 raised to 2x is also equal to 3 squared raised to x. From there, we can say that 3 squared raised to x is also equal to 9 raised to 5x minus 4. But we know that 3 squared is equal to 9. Therefore, we can say 9 raised to x is equal to 9 raised to 5x minus 4. Now that they have the same bases, we can perform the property of equality, which states that a raised to x is equal to a raised to y, then x is equal to y. So since we have the same bases here, we can now equate the two exponents. So we have x equals 5x minus 4. Subtracting 5x both sides, we have x minus 5x equals 5x minus 4 minus 5x. 5x combined with negative 5x becomes 0, giving us negative 4x equals negative 4. So, dividing both sides by negative 4, cancel negative 4, we know that x is equal to 1. For problem number 9, solve for the value of x in the given equation 4 raised to x minus 3 is equal to 256. Before we can perform the property of equality, we must make sure that the two expressions have the same base. So let's express 256 with base 4. So we have 4 raised to x minus 3 is equal to 4 raised to 4, because 4 raised to 4 is equal to 256. Now that we have the same base, we can perform the property of equality. But first, by loss of exponent, we have a raised to m raised to n is equal to a raised to mn. So from here, if we have 4 raised to x minus 3, we will multiply the two exponents. Therefore, we will have 4 raised to x squared minus 3x. Now, from there, we will have 4 raised to x squared minus 3x is equal to 4 raised to 4. So by property of equality, a raised to x is equal to a raised to y, then x is equal to y. Now we can equate the exponents of these two expressions. We will have x squared minus 3x is equal to 4. From the previous slide, we have x squared minus 3x equals 4. Transposing it to the left side, we will now have x squared minus 3x minus 4 is equal to 0. Now, we will solve for x. So we will solve for x using this magic square. We will put x squared here and negative 4 here, and then the middle term negative 3x we will put in this box. In these two boxes here, we will put the factors of x squared. So we have x and x. In these two boxes, we will put the factors of negative 4. We have negative 4 and 1. So multiplying this, we will have negative 4x and x, and adding them together, we will have negative 3x. Now that it satisfies this equation, we can say that the factors of this equation is x plus 1 and x minus 4. Then equate it to 0. Now we will have x plus 1 is equal to 0, or x minus 4 is equal to 0. From there, we have x is equal to negative 1 and x is equal to 4. Problem number 10. Solve for the value of n in 4 raised to negative n minus 2 times 4 raised to n equals 64. By loss of exponent, we know that a raised to m times a raised to n equals a raised to m plus n. So if we have 4 raised to negative n minus 2 times 4 raised to n equals 64, we will just add these two exponents. So we have 4 raised to negative n minus 2 plus n equals 64. And if we add negative n and positive n, that will give us 0. Leaving us 4 raised to negative 2 equals 64. Using the property of equality, it is easier to solve for equality if we have the same base. So, let's express 64 with base 4. And that is 4 raised to 3. So, by the property of equality, if we have a raised to x equals a raised to y, then we can say that x is equal to y. Then, let's express this in this form. 4 raised to negative 2 is equal to 4 raised to 3. Then we can say that negative 2 equals 3. Obviously, that statement is false. Therefore, this equation has no solution. Problem number 11. Solve for the value of x in the given equation. 8 raised to x is less than 4. So before we perform the property of inequality, we must first express the expressions in terms of the same base. So, let 8 be equal to 2 cubed and 4 be equal to 2 squared, giving us with 2 cubed raised to x is less than 2 squared. By loss of exponent, we have a raised to m raised to n equals a raised to mn. So if we have 2 cubed raised to x, therefore we will just multiply 3 and x, giving us 2 raised to 3x. Therefore, we will have 2 raised to 3x is less than 2 squared. So by property of inequality, if we have a raised to x is less than a raised to y, then we can say that x is less than y. So we can say that 3x is less than 2. Divide both sides by 3, cancel 3, and we will have x is less than 2/3. Problem number 12. Solve for the value of x in the given equation, 3 raised to x raised to 3 minus x is greater than 9. So before we perform the property of inequality, we must first express the expressions with the same base. So that is, we will express 9 as 3 squared, giving us 3 raised to x raised to 3 minus x is greater than 3 squared. And by loss of exponent, if we have a raised to m raised to n, that is equal to a raised to mn. So, if we have 3 raised to x raised to 3 minus x, we will just multiply these exponents. That will give us 3 raised to 3x minus x squared. So from here, we will have 3 raised to 3x minus x squared is greater than 3 squared. And then next, by the property of inequality, if we have a raised to x is less than a raised to y, then x is less than y. Or in this case, we will use greater than. So that is 3x minus x squared is greater than 2. Rearranging these terms, we will have negative x squared plus 3x, and then we transpose 2 to the other side, it will become negative 2 greater than 0. So now, since we have the quadratic equation negative x squared plus 3x minus 2 is greater than 0, we will now solve for its roots. So solving for the roots of the quadratic equation, I use this magic square. So we will put the negative x squared here and negative 2 here, and then the middle term 3x in this box. So in these two boxes, we will put the factors of negative x squared, and that is x and negative x. In these two boxes, I will put the factors of negative 2, and that is 2 and negative 1. How do I select this? We first multiply these two, and that will give us 2x and positive x. And then if we add these two, and that produces the middle term, then the factoring is correct. So now, we will group these two, and we will group these two to have the factors. And that is x minus 1 and 2 minus x. And these factors are greater than 0. Now, we have here x minus 1 is greater than 0 and 2 minus x is greater than 0. So we have x is greater than 1 or x is less than 2. So that is the solution for this inequality. Problem number 13. Solve the inequality 0.6 raised to x minus 3 is greater than 0.36 raised to negative x minus 1. So before we perform the property of inequality, we must first express these two expressions with the same base. Therefore, let's express 0.36 with the base 0.6. We know that 0.36 is equal to 0.6 squared. Now, by loss of exponent, we have a raised to m raised to n is equal to a raised to mn. From here, we will have 0.6 squared raised to negative x minus 1. We will just multiply 2 and negative x minus 1, giving us 0.6 raised to negative 2x minus 2. Going back to this equation, we will have 0.6 raised to x minus 3 is greater than 0.6 raised to negative 2x minus 2. By property of inequality, if we have a raised to x is greater than a raised to y, then x is greater than y. So from this, we can say that x minus 3 is greater than negative 2x minus 2. From here, by addition property of inequality, we will subtract negative x, or we will subtract x and add 2 to both sides, giving us negative 1 is greater than negative 3x. Now, we will divide both sides by negative 3. So we have negative 1 over negative 3 is greater than negative 3x over negative 3. And then we cancel negative 3. But note, for inequalities, when we divide both sides by a negative number, we reverse the inequality symbol. Therefore, we will have 1/3 is less than x. Problem number 14. Find the solution set of the inequality cube root of 10 raised to 1 minus 2x is greater than 0.1 raised to 2x plus 1. By laws of exponent, we know that if we have an nth root of a, it is also equal to a raised to 1 over n. Therefore, if we have your cube root of 10, we can see that it is equal to 10 raised to 1/3. And by laws of exponent again, if we have a raised to m raised to n is equal to a raised to mn, therefore if we have 10 raised to 1/3 raised to 1 minus 2x, we will just multiply 1/3 and 1 minus 2x, giving us 10 raised to 1/3 minus 2/3 x. And by property of inequality, we must first express the two equations or expressions with the same base. So, we know that 0.1 is also equal to 10 raised to negative 1. So from there, by laws of exponent, we know that a raised to m raised to n is equal to a raised to mn. So 10 raised to negative 1, here, we know that 0.1 is 10 raised to negative 1, raised to 2x plus 1 is equal to 10 raised to negative 2x minus 1. So by property of inequality, if we have a raised to x is greater than a raised to y, then x is greater than y. So, if we have 10 raised to 1/3 minus 2/3 x is greater than 10 raised to negative 2x minus 1, then we can see that 1/3 minus 2/3 x is greater than negative 2x minus 1. So, let's group all the terms with x variable. So, we have here 2x minus 2/3 x. How did it happen? We transpose negative 2x to the left side, making it positive. So we have 2x minus 2/3 x, and then we transpose 1/3 to the right side, giving us negative 1 minus 1/3. So from there, we will have 4/3 x is greater than negative 4/3. Next, we multiply both sides by 3/4, cancel 4, cancel 3, and likewise on the other side, cancel 4 and cancel 3, giving us x is greater than negative 1, or from negative 1 to positive infinity. And that's the end of our lecture. What we learned, we distinguished the difference between exponential function, equation, and inequality, and solved problems involving exponential equations and inequality. In our next video, we will learn the representation of exponential function. For supplementary problems, you may refer to QuexBook General Mathematics Chapter 3.